In this video, we're going to discuss how to put a price on the forward price. From the previous video, we have seen that the forward contract does not involve any cash exchange at the moment when two parties are entering the contract. The cash exchange only happens at the time of maturity. But the question is, what is going to be the fairly priced forward price at maturity? So to solve this problem, we will need to use a technique called the replicating portfolio. So it is based on the law of one price. Okay, it's based on law of one price. So essentially, if two different assets or portfolios give you the same return with the same risk profile, they should be priced the same, right? Otherwise, you will have the opportunity of arbitrage, as we have seen before. Okay, so if it's mispriced, then there's room for arbitrage. So the law of one price states that if two or multiple assets would give you the same return with the same risk profile, then they should be priced the same. So using this, we could replicate the payoff for the forward contracts and try to determine the forward price by the replicating portfolio. So we'll use something that we have already learned to try to put a pricing on this new type of asset. Okay, so with the forward contract, we need to specify two different time periods here. So at the inception of the derivatives, or at the time zero, there is no cash exchange, as we have seen from the definition of forward. Okay, but what is going to be the payoff if you are the long position for the forward contract at time t, which is the maturity here? That's going to be the spot price minus the forward price, as we have seen from our numerical example for the rice market here. Okay, so now our job is to try to replicate this payoff or this exact cash flow structure with things that we have already known, right? So we will try to replicate this by using a replicating portfolio. Let's call it a replicating portfolio. Okay, to replicate the payoff, they both must have the same cash flow at the same time nodes, right? So perhaps it's easier to start from the maturity here. So we know it has to include two different parts, the ST and the minus FT here. So how do we replicate the payoff of ST here? This is fairly simple, just by the asset or the underlying asset here, right? So let's move it down a little bit so we can see what to do here. So if you're going to get a cash flow of ST at time t, which means you're selling something at the price of ST, then how do you do that? Then you must buy that underlying asset right now. So what is the price for that underlying asset right now? We call it the S0 here. And since we're buying it, that's going to be a negative cash flow or a cash outflow. So the first step is to buy or loan the underlying asset, right? The underlying. Okay, so at time t, you would have a negative or a cash outflow of S0, and at time t, you can just sell it at the spot price. So you would have a cash inflow or positive cash flow of ST, right? So this part is down. This part is already done. And what about the negative FT here, right? So it seems like a standalone cash flow. So whenever we have this sort of standalone cash flow, it is pretty common. We're going to replicate it with a bond. Okay, so what can cause a cash outflow of FT here, or some amount in the future, and that is going to be a bond. So why don't we borrow something, and this is going to be our repayment for that bond. So we're going to borrow a 0 coupon bond or zeros because nothing happens between 0 and time t here. So it's going to be a 0 coupon bond. So what's the price of such a 0 coupon bond if the final payment here is going to be ft here, or the face value here is going to be ft here? So naturally you would think that's going to be ft divided by 1 plus r sum rate here to the power of t, right? If it's risk-free, then that's going to be risk-free rate. If it's some other appropriate discount rate, then just use the appropriate discount rate here. So we're here to borrow the present value of the ft here. Okay, so borrow the present value of ft, which is the forward price. Okay, and this should replicate the payoff of our forward contract here. Okay, so now we have done the replicating. The payoff is the same, and we're assuming the if the risks or the risks involved are also the same. So if the forward here is risk-free, then we're going to borrow it at the risk-free rate, and both are risk-free as well. So it must be the case that all these cash flows are identical as well. So we already have the identical cash flow at time t, then the cash flow at time 0 must be identical as well. So we can confidently write that 0 equals S0 plus ft divided by 1 plus r to the power of t here. Or we can arrange this stuff a little bit. So we put this bit on this bit here, or we put S0 here, and we multiply the discount rate for both sides, and we would have ft here is equal to S0 multiplied by 1 plus r to the power of t here. Okay, so that is how we put a price on the forward, or the forward price here. And the technique we have used is called the replicating portfolio, and we'll be seeing this in the future sessions as well. Right, so right now it is advised to go through the replicating process and try to get a feel for it. Yeah, you might not be able to grasp every bit of detail here, but try to get a feel for it and why this thing works. This is because we're trying to replicate the same cash flows at each of those time nodes. Whenever there's a transaction, we try to replicate that cash flow, and we make sure these cash flows are identical, so then we can solve for the unknown parameter here. In this case, that's going to be the forward price. Okay, again, we'll be using it in the future, and I'll see you in the next video.